All right. So far in this demo section, we have focused on Bluetooth Low Energy. However, with the STM32WBA, we also offer support for multiple other protocols based on 2.4 GHz radio. During my part, I would like to provide a quick overview of the available protocol stacks in the STM32Cube package and show existing examples prepared to make start with our products easier for you. Finally, I will then show you how you can integrate the STM32WBA6 into smart home network that you might already have with demonstration of our ZigBee solution. So, as mentioned in my previous slide, we offer a number of protocol stacks based on 2.4 GHz radio. In this overview, I will also highlight the different stack variants available, allowing you to choose the one best suited for your application. So, for example, for the BLE, there exist 6 variants with a wide range of features from the full stack with all supported features to the link layer only basic stack, which is without the host stack and is ready for a third-party host stack integration. This number of variants allows for memory footprint optimization based on the used features, so you can select the best fit for your application. All these stacks are certified for Bluetooth Low Energy 5.4. Regarding ZigBee, we do support both R22 and R23 revision of the ZigBee stack with both variants full function device, FFD, which can serve any role in the ZigBee network, and RFD, reduced function device, which lacks routing capabilities and can only function as an end device. These devices are usually the simple devices in your home, like the sleeping end devices, like for light switches and stuff like that. The SDK also includes the cluster libraries for respective revisions with numerous generic clusters implemented according to CSI specification revision number 8. For thread, we offer open thread stack implementation combined with thread 1.3. Similarly, with the support of 2 variants with different possible network roles. Additionally, the SDK supports using the 802.15.4 McLear stack for proprietary protocol implementation, and there are also available different concurrent mode stacks, which enables the STM32WBA devices to use 2 wireless protocols in one application. So this is a feature that is used for advanced protocols implementation as a ZigBee Direct or a Matter, which both will be discussed a little bit further. So having summarized the various available wireless stacks, I would like to show you what else can be found in our STM32Cube WBA package. This SDK, in addition to being freely available on our website, stgraph.com, is also published on GitHub. The package includes necessary documentation, drivers, middleware, and examples ready for use on your various boards, on our various boards, covering the most common use cases. So this is the STMicroelectronics package on the GitHub. So you see the structure used to maybe from our previous Cube packages. So the example projects are quickly available here. In the projects folder, here you select one of our development boards available. So, for example, NucleoWBA6. In the examples folders, there are projects focusing on the microcontroller peripherals and their use of it. And the application folder focused on the more complex applications for different operating systems, and also the use of the middleware as STM32WBA pen for support of the wireless protocols. So my colleagues already showed some examples from the BLE folder, so I will start from the other side. So in the ZigBee folder, you can see the very big substantial number of examples targeting different clusters, ZigBee clusters, as a fine bind or the basic on-off cluster, power configuration, temperature measurement. There are usually pairs of these examples who fill different roles in the ZigBee network, like a coordinator and router. There are sleeping end devices. You can also find complementary examples using different operating systems, as FreeRTOS or ThreadX, or you can also run the ZigBee stack an application without any operating system as well. There are also examples for distributed or centralized networks, so really quite complex number of examples to help you with the start with the ZigBee. Regarding the other protocols, you can see for thread, there are, as example, how to control the thread stack with CLI commands, or examples for basic generic co-op messages or OTA over the thread. But yeah, and also there are some examples for the concurrent modes as the ZigBee, which I will talk a little bit right now about the solution for ZigBee Direct. A little bit later about the ZigBee Direct. I would like to introduce you first to my demonstration now. In this demo, I want to show you how easily you can integrate the WBA6 device into the smart home network you might already have. So in typical smart home network, you will have some kind of central unit. In this case, this is ZigBee hub, which acts as a coordinator of the ZigBee network for these ZigBee devices. This hub then allows you to control the ZigBee devices from your mobile phone, usually with the help of some kind of access point or router. For this demonstration, I'm using like a slightly edited example project from SDK to join these two WBA6 nuclear boards to the ZigBee network as acting as a ZigBee devices with an on-off clusters. Specifically, on-off server for the ZigBee Lite and on-off client acting as a ZigBee switch. Thanks to that, after the commissioning process, you can then control the blinking of the LED on the nuclear board from your mobile phone, or on the other hand, control your ZigBee lights with push of a button. So I will now switch to my real-life demonstration. So as seen on the previous slides, so you have here the ZigBee hub with the connected already together with this ZigBee light bulb. That's how I can control with the smart home application in the mobile phone. Now what I will do is that I will join these two devices into the network, so they will appear here and I can then control them from the mobile phone. So I just add the product. I will scroll down to add any smart product or brand. And now it's starts the search. I will start the devices. You can now see the blue LED blinking. That's the commissioning process. And I have already found my nuclear boards, so I will just add them. Continue. I will add them to my virtual room here and configure the light switch to control the light bulb and the other nuclear board. So, and this is all. Now I can control the LED on the nuclear board, and similarly I can, with the push of the button, toggle the light bulb and the other nuclear board as well. So this is how easy it is to join, use our examples to join your devices to work to existing solution of a ZigBee network. This example, edited version of this example is also available on the GitHub STM32 hotspot, so you can check it out and the changes that were made to the basic on-off client through the demo and how to implement it for yourself. So, but I have here the second demo setup, and in this one, I would like to show you the new example for ZigBee Direct device. You see, you might not have available ZigBee hub, or you just maybe do not want to use it, but still you would like to use your phone to control your ZigBee devices. So mobile phone typically do not support ZigBee natively, so and that is a problem that could be addressed by the ZigBee Direct solution. So it is protocol that was defined by the Connectivity Standard Alliance, and it combines the use of these two technologies, ZigBee and Bluetooth Low Energy, for commissioning and control of the ZigBee devices by the Bluetooth-enabled devices like the mobile phones are. So in this demo, the Kbytes smart home application for iPhone is used to control the ZigBee devices from a mobile phone. But for functioning, it needs a ZigBee Direct device, the ZDD, that act as a bridge to relay the commands from your phone via the Bluetooth to the ZigBee devices. Then after the commissioning of the ZigBee devices to the network created by the ZDD, you can directly control the ZigBee devices from your phone without the need of any ZigBee hub or router or any extra hardware whatsoever. So I will now switch back again to the live demo to present you how it could be done. So in this moment, I only disconnect the hub completely. I do not need it anymore. I will put on the other device. This is what works as the ZigBee Direct device, and change the application. So for this, I will use UBC Smart Home application. Okay. Now I will need to start the ZigBee Direct demo. And okay, so the green light is blinking, so it's waiting to be connected via the Bluetooth. So create connection via Bluetooth. I can already see the ZigBee Direct device, so I will start connecting to this board. You can see the process ongoing. Okay. So we need to wait a little bit moment to explore the solution, the available clusters. So, and now I want to add some other devices as well. So for this, I need to reset the devices to start the commissioning process again. So first the light bulb. So light bulb starts searching again. I have restarted the nuclear boards, and now I'm searching for the new ZigBee devices. So I can see the ZigBee light bulb has been found already. Now I'm waiting for the nuclear boards as well. Okay, so I can see now all of the devices in the application. So now I need to finish the configuration. For that, I need to create again some virtual room. Virtual room here ST. I will add the devices there. So I will select the light bulbs. And now I can already control the ZigBee devices from my phone. So building control. I can see the SG room. And you can see I'm able to control the ZigBee light bulb from my mobile phone, even via the Bluetooth. So I can now turn it on and turn it on again. As well, I can control the ZigBee devices made from the nuclear boards. So now I control the LED here and on the ZDD device as well, because it's also have on-off cluster on it. And I can do the same thing with the binding as before. So I need to, for the light switch, I need to create a binding for the control of the ZigBee devices. So for example, this one. And now I can again control with the ZigBee light switch made from the color board, the ZigBee light bulb. So this is how easy it is to use it. And you don't need any ZigBee hub. You just have enough it is to have a one ZigBee board and a nuclear board, and you can control your ZigBee devices you already have. More info about this demo could be found on dedicated ST wiki page. There are also information about how the ZigBee Direct is defined, and also the code is available from the official SDK and also STM32 hotspot, the edited version. So for summary, I wanted to show you in this demo what we offer, that we offer a wide range of RF stacks with number of variants covering all different use cases. I would like to highlight the WBA6 is ready to be incorporated into the existing ZigBee networks thanks to the maturity and interoperability of the solution. And at last, with the demonstration, I wanted to invite you to try yourself the ZigBee Direct demo, which is interesting extension of the ZigBee protocol, and solution is an example is available on the wiki and STM GitHub STM32 hotspot.